including ITS deployments, managed lane projects, and connected vehicle operational tests. Jim is also a member of TRB's Highway Capacity Manual Committee and FHWA's Traffic Analysis Team, which supports the analysis, modeling, and simulation program. He holds a Bachelor of Science in Civil Engineering and a Master of Civil Engineering from the University of Minnesota. And then I'll just introduce kind of everybody, so you guys can just kind of go right after each other. And Bob Fry serves as the Planning Director for the Tampa-Hillsborough Expressway Authority. Bob has more than 30 years of planning experience working throughout Florida and the United States. Bob is a project manager on autonomous vehicle project coordinating the Expressway Authority's initiatives at the federal, state, and local levels. He holds a Master of Public Policy degree from Baylor University and is a member of the American Institute of Certified Planners and a graduate of the International Bridge, Toll, and Tunnel Association Leadership Academy. And Jay Hippis has been working for the Minnesota Department of Transportation since 2005. His roles at MIDOT include Design Build Program Manager, Director of Innovative Contracting, and his current position is Director of the Office of Traffic Safety and Technology. Jay is a graduate of the University of Minnesota with both a bachelor's and master's degree in civil engineering. So please help me welcome Jim McCarthy.
Thank you. And it's exciting to be here. For a long time, many of us have been working on research and development of connected vehicles, and we're on the verge of deployment. The pilot projects are an important part of that, and I'm happy to be here to tell you about what's going on. And I'm very glad to see Minnesota engaging very enthusiastically in this program. It's important to me as a Minnesota resident and important to all of us. So it's great to be here. The Connected Vehicle Program started really about 20 years ago. The first person I worked with on it was Doug Difford. It's been a while. And we've spent significant resources developing the technology in the lab and on test tracks, and we're just beginning to deploy it in the field. We're excited about that, and I think that some of the key reasons of the Connected Vehicle Pilot Program, key reasons we're doing this is first to validate what we have learned in the lab. Does this really work in the real world? Is it doable? We believe it is. We believe it's very important to meeting our goal towards zero deaths with this technology. So, second, and just as important, is this is quite a learning curve for the industry and the agencies. So the pilot projects are critical in getting people's hands on this equipment and getting it deployed and learning from it, finding out the difficulties of field deployment and integrating it with our systems. So before we go any farther, I need to work on a definition, because this has been something that probably has troubled us and confused people. There's two technologies in operation. One is autonomous vehicles, and the other is connected vehicles. Those two marry up into the connected automated vehicle. So what you're seeing on the road right now are some levels of automation, autonomous. There's 5 levels, and you're seeing level 1, level 2, and a little bit of level 3, which are really driver assist technologies. At level 5, there are cars on the roads right now in states that allow it on the public roads. Minnesota will be testing one of these. It's testing it right now, I believe, but not on public roads. So different states have different rules right now. But the autonomous vehicles rely on sensors, onboard sensors, and onboard computing to help the driver navigate. So, and at level 5, the driver is not needed anymore. The Google car you see in the picture has no gas pedal, no brake, no steering wheel. It drives on its own. So that's where we're going. Believe it or not, it's the way it's going to happen. But there's going to be a long transition in between, and that's what we're working right now. So then there's a connected vehicle, and the difference between the connected and automated is this vehicle has a radio in it called the DSRC. It also has a cellular, of course, that connects to other vehicles and connects to the roadside. And this is a critical element of accomplishing our mission of not having no crashes. The autonomous will get us a long ways, but it won't solve every problem. So the connected vehicle adds a level of safety to the car that will prevent crashes in inclement weather like we experienced. Like I was talking to a commissioner from Blue Earth County, growing up in northern Minnesota, in blizzards you can't see anything. You can't see the front of your car. But connected vehicles can see each other. And I've ridden in these at Brainerd International, and it is amazing to have your car responding to vehicles that you can't see. They put up lines, put up barriers so you can see the car and ask us to drive to an intersection, keep our foot on the gas. And there's the car coming the other way, and my car could stop. So it's a pretty amazing technology. So that's what the connected vehicle pilots are testing, is that part of the system. The autonomous is happening through the industry. Connected is a coalition of auto manufacturers and the government's agencies developing the technology. And there is an organization called CAMP, which is our partner with the automakers to do that. So I'm going to show you a short video because it's almost take me all the rest of the day to explain all these technologies. So I'm going to show you a couple. In the connected vehicle program, a lot of what we've done on the test tracks in the labs is test applications. You think your phone being the car, the applications on your phone are the stuff we're testing. And that's what the pilots are testing, is these applications. So I'm going to show you a few of the applications. Right now we have 48 ready for deployment in some form. I'll show you about 5 or 6 safety applications. Run with this program, run at the pilots.
Imagine a future where vehicles talk to one another and to critical infrastructure. This connected vehicle technology can change our transportation system as we know it by enabling safe, interoperable, networked wireless communications among vehicles, infrastructure, and personal communications devices. Connected vehicles provide drivers with 360-degree awareness of similarly equipped vehicles within a range of approximately 300 meters. This secure system keeps personal information private and does not track your vehicle. Drivers will receive warnings that inform them of potential hazards through a visual display, seat vibration, or tone. These are only warnings. The driver remains in control of the vehicle at all times. However, the technology can also support limited automated functions in which the driver only sees partial control of the vehicle. Warnings can help drivers respond quickly to avoid potential crashes. For example, the Intersection Movement Assist application warns drivers when it is unsafe to enter an intersection. The Do Not Pass application warns drivers when it is not safe to pass a slower moving vehicle. The Emergency Electronic Brake Light application notifies the driver when an out-of-sight vehicle several cars ahead is braking. And imagine the value of this blind spot warning application, which lets this commercial driver virtually see what's happening in his or her blind spot. Connected vehicles can communicate with smart roadside infrastructure like rail-grade crossings to alert drivers when a train is coming, even if the driver cannot see or hear the approaching train. Connected vehicles can help with weather-related traffic and safety issues too. This is especially true with conditions such as black ice, where the weather may not appear to be dangerous, but the roads are slippery. Information collected from multiple connected vehicles can help determine when a potential hazard exists, such as icy roads, and warn drivers before they experience them. Road weather data from the vehicles can be sent to traffic management centers, or TMCs, providing detailed, real-time information to help monitor and manage transportation system performance. The centers can then take actions like adjusting traffic signals and speed limits, notifying maintenance crews, dispatching maintenance vehicles to the road, and broadcasting warnings for motorists. Motorists can get real-time road weather information from in-car displays by dialing 511 or by listening to highway radio stations. Motorists will be able to get road weather information on their personal devices before leaving home. Connected vehicles can even help us to reduce our carbon footprint and facilitate green transportation choices. Eco lanes are similar to today's HOV lanes, but with a big difference. Motorists in these lanes agree to drive eco-friendly vehicles and drive at a speed that conserves fuel. Drivers will be alerted about the proper speed with dynamic message signs. Connected vehicle applications can help vehicles to reduce idling and unnecessary stops by communicating with smart traffic signals. Traffic signals broadcast data about their current signal phase and timing, and systems inside the vehicles use the data to determine speed advice for drivers. Drivers could then adjust their vehicle's speed to pass the next traffic signal on green or slow down to a stop in the most eco-friendly manner, thereby saving fuel, reducing emissions, and saving drivers money. Connected vehicles.
All right, I'll cut it up there. There's a number more. I just wanted to show you what some of the applications are that we're testing in the field right now. Many of these will be tested in the pilots we're going to talk about now. So a couple years ago, we did an RFP to do field testing, large-scale field testing. I don't remember the dollar amount there, but it was in the tens of millions of dollars. We wanted to award to agencies or states that wanted to test the technology and demonstrate these applications and learn from doing. So that we spent about a year in concept development with the pilots that were selected. That was New York City, state of Wyoming, and Tampa. Actually, I don't have your name written up here, but you'll explain it. It's not a state agency, it's actually a private toll agency was selected. So those groups spent about a year and a half once the concept was agreed to between them and US DOT. They spent about a year and a half in design, deployment, and testing, and we're just approaching the turn-on date for those systems. And so took us a while to get there, but this is our first effort, and took a kind of a go slow approach to make sure we had it figured out when we put it out in the field. So we're looking forward to that field test and learning from that. So I'm going to talk about the Wyoming test, pilot test, and then the New York City test, and then we'll call up Bob and he will let us know what he's doing down in Tampa. Probably not fighting black ice. I was fighting black ice today. So Wyoming, first pilot, very rural state, but there are rural applications, particularly around commercial vehicle traffic, and they've got a nice test looking at reducing crashes of making it safer for trucking companies. Second, New York City. If you can do it in New York, I guess you can do it anywhere. And this is a big scale test. 8,000 vehicles, testing both the vehicle that connecting to the infrastructure, the roadside, to the signals, and connecting to each other. And then the Tampa Hillsborough Expressway Authority has I think a very interesting test that's looking at both freeway and arterials and pedestrians, kind of a wide variety of applications through the metro area. I'd say that one's probably closest to the one that Minnesota submitted. Unfortunately, Minnesota didn't win, but it would have won a whole lot of work along with it. So we let Bob do that. So we'll hear how that's going. So If you look up in the right corner, you see 400 vehicles equipped. It's about 100 of the DOT fleet, 150 partner trucking units, and then some other state vehicles with being outfitted with the onboard radio system called DSRC that can communicate with other vehicles and with the roadside. And there's kind of 4 primary applications. If you look at the large white circles up in the right, high wind warning. I first saw that, I wasn't really sure why you'd have a high wind warning, but if you've driven through the mountains, you get a lot of crosswinds and heavy winds that are difficult for trucks to handle, even difficult for RVs and those type of things. So they're measuring the wind speed and communicating between vehicles. As one vehicle hits a wind pocket, just like the black ice, it can communicate to ones within 100 meters or 1,000 meters, I believe. So it can notify other vehicles around it. It's having trouble. It can notify the TMC it's having trouble. And then, so that's the first application. Second is truck parking notification. If there's weather up ahead or trucks experiencing trouble, they get connected to the truck parking system, which you see at the bottom, that can either assign it a truck parking space or give it directions on where to go. And lastly is low visibility over on the right side. They're in a weather condition, fog and snow. Connected vehicle-to-vehicle technology helps them navigate that. So that's kind of what the Wyoming one looks like. They've built it on existing technology, and a lot of this stuff is really just building on existing stuff we're putting out, signal systems. In this case, it's built on weather stations. Just like Minnesota, they have a significant deployment of weather stations. And you see it by the dots in the map. So they're using that as their communication technology to connect back to the center and to each other. So the objective of the project is to reduce the number of severe crashes that are related to weather on the I-80 corridor. So here's the deployment areas. It's all across the state. Some of the testing is just in the areas that are boxed out there, but they will have communication on the whole corridor. And they're just testing 5 of the applications there. Like I said earlier, it's 48 applications, particularly related to weather and warnings for the vehicles. So, and then on to New York. Much larger project. If you look at the blue boxes up at the top, I'll just kind of go around counterclockwise. 100 vulnerable user road devices. That's either a wearable or a phone that someone's carrying that's going to connect to the system, connect to other vehicles when someone's walking across the road or a bicyclist. So that's the first one. And over towards the left, you see 700 MTA buses. All the buses running on the corridors I'm going to show you in a minute will be equipped with radio units so they can communicate with the road system and with people that are around them. For example, a pedestrian that walks in front of the bus, which is typically the typical case of a pedestrian getting hit is they get off the bus and walk in front of the bus and get run over, or the bus turns and runs them over. So very often that the user of the bus is the one getting hit. So they're going to be testing that. Next is 1,000 sanitation DOT vehicles. That's of course New York City DOT. And then 5,850 taxis will be equipped with vehicle technology. And then lastly, 400 UPS vehicles. They will have 350 roadside radios, which you'll see in Bob and Jay's presentation. This is the radio that connects to the traffic signal controller, a very small little device that these cars will be communicating with. So that's their layout. And they have quite a few applications on a variety of roads through the Manhattan area. This is kind of hard to see, but on the left, on my right, you see a couple of the avenues in Manhattan, pretty high volume roads. If you've been there, pretty packed with cars, packed with pedestrians, packed with cyclists, packed with transit buses, and a lot of crashes there. They have over the last 3 years, they've had 5,000 injury crashes on these 4 streets, 20 fatalities. It's a busy place. Then Flatbush Avenue in central Brooklyn, I believe that includes the Brooklyn Bridge also. Again, a very busy street. Average travel speed about 15 miles an hour on that road. You can walk about as fast as, in the morning peak, you can walk about as fast as traffic moves. 35 intersections, 1,000 injuries, 8 fatalities in the last 3 years. They have a real intersection safety problem that they're going to be testing a number of applications to help with. And lastly, FDR Drive, an old 1930s style freeway, kind of the vision of Robert Moses, one of the few that got built. Very poor geometry, a lot of crashes. So there's a whole bunch of applications. We're not going to read them all. They're testing 15 different applications. At the bottom you see 10 to 14 on that list. They're testing four or five different vehicle-to-vehicle technology applications, and the first half of that list is primarily intersection safety type applications. So that's a very large-scale test. Hundreds of intersections, hundreds of roadside devices will give us a good shakedown of how this technology works. So one of the intents, I could say third intent of this pilot project was to kickstart this deployment. And we hope that all the other people that had applied, it generated enough interest that they would continue to move along. And AASHTO felt the same way. We only had enough money to do so many pilots and learn from them, just because of resources and staffing. But a real important part of this was just to jumpstart this whole effort. And this is the current state of deployment. And I believe this is actually a little bit out of date. It's a couple months old. But these are all different deployments we have going right now, either in design or that are in the field, testing the connected vehicle technology. So we're seeing it in most every state. I believe Minnesota's might be a little out of date. The brown are funded with federal funds. The kind of yellowish green are funded with state or local funds. So we think the pilots served a very important role in jump-starting this program, and Jay's going to talk about what they're doing locally, and that was really important, because the only way this is really going to deploy is if we got people starting to use it and learning from it. We couldn't wait for some special funds to make it happen. So that's pretty exciting to see it happen. AASHTO is a big part of that. I know many are part of AASHTO, and they have what's called the SPAT challenge, which is challenging DOTs to deploy this technology. So that's it. Are we doing okay on time? Okay. I can take a couple of questions, and we'll probably leave some time at the end for questions also. Yeah. Brian.
Most of the literature that I've been reading on the coming technology changes indicates, and your video kind of shows this, that there needs to be a great and powerful laws behind the curtain managing the network. Because like the internet or like our electrical grid, at some point something can break. And so somebody needs to monitor it and take steps to that. Is it NINDOT's belief at this point that the safety team will play that role? And or have you thought about it, or get John, who would do that?
I'll let Jay answer when it comes up, but I would expect many different agencies to deploy this. It wouldn't just be state DOTs, it may be local agencies, it may be cities. The key part of the R&D was to make sure all these systems work together. There was a long process of standards building so that the systems work together. When devices fail, you got to have a failure moment. One of the benefits I see of having both the autonomous feature and the connected feature is if one fails, the other will be working. If you just rely on one particular type of sensor, so my thinking is that these systems have to kind of work in a redundant fashion. So the only real powerful Oz in this case is NHTSA. And NHTSA is right now in rulemaking to mandate this radio system on the car, which isn't a big piece of equipment. Most of the computing power is already in the car. We're just broadcasting what the car's already generating. So I call that the Oz. Any other questions? Yeah. Oh, Mike.
Jim, how does it work for gear? You connect with the car.
Well, the autonomous part of it is really the sensing piece, and that's using radar, video detection. So that's already showing up on some cars. My car has that, where it can sense people and animals. So that's really in the autonomous piece. Unless our deer carries cell phone, but I don't expect they will. Maybe they will. But the sensing devices on the cars are pretty powerful. You look at the video stuff Mercedes has now, the 3D technology in their camera. It's pretty amazing what's on cars already. So, thanks, Mike. All right, I think we'll move to Bob and learn about Tampa.